Hello student, today we are going to see NCERT exercise problem. It's a 9th chapter, first problem, class 11, physics exercise problem. We are going to do the solution. If you want more exercise and example problem means you can go and see in my playlist. Okay. It is a first problem, book back we are going to see. It's a 9th chapter, first problem. The question from mechanical properties of the solid. It's going to be class 11 physics. Okay. Here there are taken two wires. They asked about the Young's modulus question. Okay. A copper wire and steel wire. They are given changing length for copper wire and steel wire. Area also they are given. They asked about the question is actually, it is a comparison, like a ratio between steel wire and copper wire. Both the ratios we should take. Okay. These are the data is given. Okay. Steel wire length is given. L1 I am taken as a steel wire, or LS also we can take it. Okay. The area of the steel wire also we can, it's given, that's going to be area of steel wire. Copper wire length also is given and copper wire area also is given. Okay. Now the Young's modulus of steel wire and copper wire ratio we should find. Okay. It's a very simple problem. Okay. First we will see what is a Young's modulus. Young's modulus is equal to stress by strain. Okay. So stress is called force per unit area. So force per unit area. Strain is called changing length by original length. If you are modified, denominator directly will go into the numerator. Force into changing length divided by area into force into original length divided by area into changing length. This is what we can get. Okay. First I will write the steel equation. Young's modulus of steel. Force per unit area applied for the steel into length of the original length of the steel and changing length of the steel. This is what we can get the steel equation. This everything is for the steel wire. So you can take it as a yes, everything steel wire. Okay. If you want copper wire, the Young's modulus of the copper wire, the same force applied copper wire, it is area for the copper wire and length for the copper wire and changing length for the copper wire. Okay. This is a two equation. So it is a second equation. It is a first equation for steel wire and copper wire. Okay. Now the data know both are equal changing length. So the length of the copper wire is equal to length of the steel wire. Both will get elongated with the same length. Okay. The force load which we applied copper wire and steel wire, it's going to be the same. These two in a question only they are given. Okay. Now I am going to take it with the ratio. So Young's modulus of the steel wire divided by Young's modulus of the copper wire. Okay. What is the steel wire equation? Force for steel and the area for the steel, length for the steel and changing length for the steel. Okay. Force for copper, area for copper, length for copper and changing length for copper. Okay. So already I told you some of the data is equal, which is given in the question. That's called force applied is equal, changing length is equal. Okay. Only this two ratio we should take it. Now will be taken with the Young's modulus of steel wire by Young's modulus of copper wire. Okay. Now what is a changing length of steel wire by area of the steel wire and changing length of copper divided by area of the copper. Okay. Denominator directly will come into the numerator. Length of steel divided by area of the steel into area of copper divided by length of the copper wire. Okay. Now we'll apply the value. So this is a ratio of steel wire by copper wire. You can do opposite way also. Copper wire by steel wire also you can do. First the value of steel wire. The length of the steel wire which is given in the question, that's going to be called as a 4.7 meter. Okay. So then area of the steel, area of the copper wire. Okay. So the second wire which is going to called as a 4 into 10 power minus 5. Next area of the steel wire, it's going to be 3 into 10 power minus 5. So length of the copper wire which is given as a 3.5. Now the next step we should do the multiplication, then you will get the answer between the ratio between these two. Okay. So 10 power minus 5 will get cancelled. Directly you can cancel the power. Okay. So remaining, so the ratio between these two, steel wire by copper wire, this is the value we are doing, 4.7 into 4 denominator we have 3 into 3.5. So 3 into 3.5. Slowly you can do the multiplication. For 4.7 into 4, that's called 47 into 4. So 18.8 we can get. Okay, numerator 18.8 we can get. Okay, denominator is 3.5 into 3. So 15, 9, 10 will be there, one decimal, 10.5. Okay, if you want make it round number, so numerator 10, denominator 10. Remove the decimal, the calculation will become little easy. So numerator will be 188, denominator will be 105. Okay, now you can take it the normal division. Okay, calculation. See here, I will do here just 188 and 105. So 105 will be one time. Okay, remaining I am writing 3. So here 3 will come, here 8 will come, here 0 will come. Okay, then put one dot, here 0. So 105 will be 7 times. So will be have 35. 735, it's going to be called as a 7 times. Okay, so then 2 will come here, 10 will come here, 5. So 7, 12 minus 3 will have 9, then 0 will be here. Approximately this close to 9. So the Young's modulus of steel by Young's modulus of copper is equal to 1.79. It is a ratio. We don't have any unit. Okay, this is a final value. Okay, thank you for watching my channel. If you like my channel, please subscribe. If you want more video, you can go and see in my playlist. Okay, thank you.